Hi, good evening, everyone. Thank you for the opportunity to speak to you guys tonight regarding air-to-water heating. My name is Brendan Grace. I work for Wales Darby. We are a manufacturer's rep here covering the tri-state area, and our product lines are in the HVAC world. And our specialty is really in hydronic heating. We are the manufacturer's rep for Taco, which is a circulator manufacturer, plus all hydronic components that are around the boiler. So everything except the boiler in the heating world is can be a Taco product. So we're involved with them. We're also involved with some other lines. We've done a lot with Fujitsu, so we have a good experience in the refrigerant side of your heat pumping and heat pumping, changing over from from fossil fuel to electric heating. So what I wanted to bring to talk to you tonight about was the air to water. Your group, as you know, you've been obviously doing passive heating, passive architecture in heating. And what I was looking to present to you is another option regarding converting from fossil fuel to electric hot water, electric heating. And one of those ways to do that is using refrigerants, and which is obviously most of you have a lot of experience with. But the other is air to water. This is becoming a growing trend. And there's some reasons for that, which is what we want to go into tonight. So air to water. So the offerings coming, we're using lots of different refrigerants right now. Right now we're at the refrigerant R32, which is a A2L version of restricted refrigerant, which has some flammability, but not a lot. We are going to be heading towards some newer refrigerants that are going to be very almost flammable with propane. The advantages to that will be the ability to make the water hotter. Obviously, the biggest issue regarding heat pumping in regards to making hot water for domestic and making hot water for heating is obviously getting the temperature up. Right now, we're kind of around that 130-degree mark. In making domestic hot water, especially, we kind of need it to be a little bit hotter to get the recovery so we can use less storage. And on the other side of it, for heating, if it could be a little bit warmer and when the temperatures get colder outside, like how do we extract heat from cold air outside and then transform it to heat indoors? So that's where the world of refrigerants are going and what we're going to do. So what is air to water heat pump? Well, it can be your standard. It's a heat pump in that it can generate heat and then put heat in the building, but it also can be a chiller, and where it can now take cold water and send cold water into the building. So it can do both heating and cooling. Instead of being heating and cooling of air, we're heating and cooling water. And when we do that is now we have hydronics heating and hydronics cooling. So it allows for tremendous amount of flexibility. Okay. So it does both. The other thing that's about this that we'll talk about too is that it's an all-in-one appliance. So it's like a refrigerator. It basically take it out of the box, drop it next to the house, plug it in, and you're kind of good to go. There's no requirements for the AC guy to run refrigerants and then dealing with all the complications of refrigerants. I got to make sure I've sized the piping right. Have I run to how long did I run the piping? How much refrigerant I put in, and setting the pressures and getting all the air out and all those issues that come up with refrigerant running. This is not the case because this is a whole enclosed system that you don't touch the refrigerant side of things. You're just touching the water. So it really, now you're just dealing with the plumber and the guy that's doing the hydronic heating, not worrying about the refrigerant guy, which really lends to simplicity, which is obviously what we're looking for. Okay. So why air to water? Well, the ultimate is that it gives you tremendous design flexibility. And obviously that's really important for you guys. You guys are you're out to design houses that are optimum in inefficiencies. But in the bottom line of it, you want them to be aesthetically clean and aesthetically nice. And you also want them to be comfortable, because that's the main part of a home, is making a house comfortable. So with this air to water, the beauty in it is you have the flexibility of hydronic heating. Hydronic heating allows for ease of zoning. It also, for the amount of BTUs water carries compared to running ductwork, is a lot less room. And the beauty in it is you can really foul up water and it'll still work. As long as you can make piping do loop-de-loops, as long as the water gets there and it'll transfer either the cooling or the heating. It lends to tremendous room of error. Okay. Whereas, as you guys have been experiencing with the world of refrigerants, unfortunately, it's not very flexible. It has to be sized perfect and it has to be installed perfect. We're dealing with the newer refrigerants are running really high pressures. They're running 400, 500 PSI. You're running them 2 units. And now the problem is, are you sizing for your air conditioning or are you sizing for heating? And the problem is that they're both not equal. In air conditioning, you're trying to cool a house from 95 degrees down to 75. But in heating, you're looking to go from 35, 45 degrees all the way up to 75. So those requirements are dramatically different. And the issue is with refrigerants is, if you oversize on the cooling side, that the unit, you're oversized, what happens is the units don't work properly because you're not able to deliver the air over the coil to help with the transfer of fluids, to allow for the coil not to freeze up, because you don't have enough air going over it because you're not sized properly. So it lends to lends to the issues of dealing with refrigerants. Not to mention things like did you pipe it right? Is it slanted properly? Because you got to get the liquid back to the compressor so that it doesn't freeze up. And you're also dealing with very high pressures in a very thin copper. So, the length of time of the lifetime of these units isn't very long because of what we're dealing with. In water, we're dealing with water. We're sending water out through piping. And in this day and age of PEX tubing and everything else, it even lends to being easier to do it. We can integrate it with your existing hydronic system. We can or a geothermal system, or whatever you may have. Or if you're starting from scratch and you're redesigning it all over, you can do it. Now, existing sounds like, hey, in some of your homes, a lot of you are doing, the older homes in Manhattan, and they're around this area. They have cast iron radiators. They have, and that aesthetically is pleasing to the house because of the age of the house. You don't want to lose that character in the house of the heating. Well, lo and behold, you can use those radiators, and now in some ways they'll actually work better because we're running only 130, 140 degree water through them instead of 180 degrees. So they're not scorching hot. So they'll actually make the house more comfortable because it's on all the time. So it's always warm. So it allows to warm the room better. Now, you've got a modern kitchen put in. You put in tile, modern bathroom. There's a tile floor. You want to put radiant in that floor. Well, guess what? You can do that. You can put the radiant in there and have your cast iron radiators. And now upstairs, you've got some baseboard. Well, we'll put in baseboard. So it just lends for a lot of flexibility in what we can do. And especially for what you guys are doing, you're just, no one project is the same, right? They're all different. They all have their own characteristics. So this will lend you to doing that. You also can make the hot water, the domestic hot water can be made with it. So there's a lot of good pluses that go with using this air to water. So like I said, look at the difference. I can run all these BTUs through a 3/4 inch pipe as opposed to match it. I've got to use a 14 by 8 inch piece of ductwork to move that amount of air. So that alone, again, space saving and things like that. It's just the convenience of running hydronic heating. It is just the most flexible way to heat a home. There are two kind of types of systems regarding heat pumps in this world. One is the monoblock, which is kind of what I described before. The monoblock system is basically is a complete package, like an appliance, goes on the side of the house and it's all done. Then they do have a split design where you have the unit outside and you move the transfer between the cold and the heating and the water to a unit that's inside the house. So you are running refrigerant lines into the house, into this one unit. Instead of running it all over the house, you're just running it to the basement or whatever it is, whatever you need to put the inside unit. It just, again, this is just another type of offering. Again, with that, you'd have the disadvantages of having to have a refrigerant and have a guy in, but you're running small piping, and there might be just logistically just some better ways for the reason for having the water in the house, the transfer being in the house instead of outside the building, just easier for access and to get and where all the products are. All the equipment is going to be located. Okay. So again, this is kind of give me a summary of what you can do in the house. So you have your unit on the outside of the house, and the unit is piped hot, and the two water pipes go from the unit into what we call a buffer tank. So we put a buffer tank is in the house, and then from the buffer tank becomes the source of heat. It's a storage of the hot water or the cold water, depending on the time of year. And then we are off of that, we're piped to all the different types of emitters throughout the house. So like I said, you can mix and match this. You can have your traditional baseboard. You can have you can have radiant heating. You could have, again, you want to use the old cast iron radiators in the house, you could do that. You want to do more modern with the thin wall heaters, fan coil units, or the wall units like the mini splits, and put them up on the wall. Whereas you want to supply heating and cooling to those, so you put those type of emitters in. But again, you can mix and match. You can have the air handler upstairs in the attic, and that just is done for cooling. So come the heating season, we're running hot water through the emitters in the house for heating. And then come summertime, we switch it over. It's running in reverse. The tank gets full of cold water, and we're now running the cold water up to the handler, and we're blowing cold air out through the air handler instead of to cool the house. So it just lends for tremendous flexibilities in the ability for you to design around the house and to make the house comfortable. So that's kind of what we're looking at here. So what does it look like? Like I said, it's in a refrigerator. You know what your refrigerator looks like in your house. You have the bottom piece has got the hot air coming out, and inside is the cold. It's kind of the same thing. You've got your all-in-one, and down on the bottom is the compressor with the heat transfer. And during the summertime, our circulator is taking the water, sending it into it. It's going through the heat exchanger. It's getting hot, and it's coming back into the building. And in the summertime, we go in reverse. It sends the water through the unit, gets cold, and then comes back out. It comes out, and it sends the water in, and then comes out cold. And then we have cold water going to our emitters, to our air handlers throughout the house to do air conditioning. So it can be a way to do both, or again, if you want to just do heating, you can do heating. So where can we use it? Like I said, We can use it in your new construction where you're laying out the whole job, so you can mix and match the newer type of heat emitters in the house, or we can retrofit it to an older house or an older building. What becomes really important in this case, really, with this is unlike the refrigerant systems where you're worried about the entire house's calculation. You still are worried about that in this sense, but you're not as concerned with oversizing for one season or the other because we're heating and cooling water. What you're just worried about is the emitters through each room. Are we putting enough baseboard to heat the house, to heat that room during in the heating season? Because we're dealing with lower temperatures, so we may have to run a little more baseboard than traditional. Or the type of emitters, what size air handler are we putting on the wall unit, are we putting on the wall to give us the heating and the cooling? But again, we're not too worried about it being perfect because we're running water. And so hot water is running through it. It's not going to freeze the coil, and it's not going to overheat the coil if the air is going over it, if it's a little over big. So that's really the important thing. And the beauty on the two is the buffer tank. The reason it's called a buffer because it buffers between the heating system and the unit outside. And it's used a lot even in the condensing boiler world because what allows to, if we're oversized a little bit, the buffer tank buffers so that we're not going to short cycle the unit outside because it's a little oversized for the heating season because we're sized for cooling, or we're oversized for cooling, we're sized for heating. The buffer tank keeps it as a buffer between the system to allow the unit outside to run in good cycles, not short cycling. So that's kind of what we're looking at. Okay. So again, distribution could be any of these products. Okay. So the ability on the units is the air to water heat pump. Right now, they're sized generally from a 3-ton to a 5-ton. So it's like 30,000 BTUs of heat and 60,000 BTUs. That's kind of how it's done. We can do heating, cooling, and we can do domestic water. You can pipe in domestic water. We'll kind of talk about that in a minute. And basically, you're looking at temperatures where it'll cool the water, down into the 40s, low 40 degrees. And then in hot water, it'll do like up to about 130 degrees. So that's kind of what we're looking at to give you those things. All right. They run efficiently. We've got the DC compressors, so they modulate up and down. All those things are still driven to give us, from a COP ratings, a very good rating. So like I said, around 2 units, 30,000 BTUs of heat to 60,000 BTUs of heat. This would be a 3-ton and a 5-ton unit. We do use, now with these, the difference is because we're sending the water outside, you will need to put glycol in. So the glycol becomes like an antifreeze that's put in the systems. One of the advantages of doing a split system is you don't have to put as much glycol in, depending on what you're doing. Especially if you're not using it for cooling, then you don't need to put any glycol in at all because everything is in the house and you're just using it for heating. When you're going outside, we obviously have to be concerned with freezing. Places where there's really, really deep cold temperatures, that's where the refrigerant, the split system may be better. You still will need some glycol, but because the Arctic cold outside, you may not want to have water go outside the building. So for us in New York, in the climate around here, we don't really have those issues. But for some of the people in the middle of the country, Minnesota and things like that, those kind of system may not be, a monoblock may not be the type of system you need. So this is kind of what a kind of pencil drawing of what you're looking at is. You've got your unit outside. We've got a circulator that takes the water and sends it in and out of the buffer tank. The buffer tank basically replaces what was the boiler in the house. So all the piping to the buffer tank is in a hydronic system is the same as if you were piping it to a boiler. You have your external tank, you have your feed valve, and then you have your piping off of it. And again, it can be as many zones as you want it to be. It doesn't have to be just one zone. It can be, 3, 4, how many rubber zones you need. And the tank can be, the tanks go in sizing depending on how many BTUs you have. And again, with these units, you can bank them. You can put 3 and 4 and bank them together. Just put in the bigger so you have a house that's bigger than 5 tons. Then you can bank them, and you can put in a buffer tank to do more, to do a larger system. So that can be done. So again, the split system again could be a place where, like I said, Arctic temperatures where you may not want to have the water go outside, even with glycol. It's so cold that you just don't want it. You could bring this moving inside, or again, if you just give you a look like, or even in here in New York where space is a problem or logistics of getting things in and out, it might actually be easier to put the unit outside and put the unit in the basement and just be able to run a set of refrigerant lines to it. Might be easier. So again, this is kind of what it would look like. Again, it's just feeding a buffer tank, and the buffer tank then feeds the system. And then there's all these kind of different equipment that comes with it. You have your air handlers, you have your emitters, thin walled fan units for heating and cooling. Or again, if you want to do baseboard or any kind of radiation, you can do that. This would show a air handler. Now this would be a SpacePak kind of setup where they're using high velocity. But again, the beauty in this is it doesn't have to be this. If you want to just do a traditional air handler with traditional sized ductwork, you can use that type of air handler as well. Or if you want to use like a SpacePak with the high velocity, which uses a smaller ductwork, from a spacing, trying to get air conditioning to the downstairs of the house or a couple of rooms downstairs, this is a type of system that can be used for that. So this would be a wall unit to be wound on, again, similar to your mini split type setup, except we're running hot and cold water to it. We're running PEX tubing, which is fairly easy to run. And again, we're not really worried about things like refrigerant leaks in walls and things like that. Well, we're not worried about that as much with these type of units. Okay. And then you have your wall emitter, same thing, got the little fan in it, can be used for heating and cooling. So this one might be these are kind of units you might use on a brand new gut job where you're gutting it and the whole house is being redone, the whole building's being redone. Okay, so now this is your basic system. You've got your two circulars, so it's kind of your primary secondaries, if you guys are familiar with that term. And your buffer tank, again, is the buffer between the heating and the unit outside. All right. Now, one of the other things that comes into this is needing more BTUs. Where would you need more BTUs? Well, one of them would be just for some colder temperatures, hybrid heating. Hybrid kind of it's a great word. And it's funny, nobody seems to want to, we all know about hybrid cars, and there's kind of a push through it, against it. We want to go all electric. And in the heating world, you want to go all electric. I know for you guys, that's kind of your main focus, to go all electric. But in a case like this, you could put in a boiler. So you could, if the building's got gas and they're allowing you to keep it, you could add the extra tank in the extra boiler in, and pipe it in to give you an extra BTUs during the heating season. It also could be used when you're trying to make hot water. You could use it to help you make hot water, and in that case, you're adding some BTUs to make the hot water, so that your storage doesn't have to be as big and your recovery is quicker. So having it as a hybrid system where you're using it to help to make hot water and on the very cold days. You could also use an electric boiler. There's a company called Electro that make electric boilers. So in that case, where you don't need a lot of BTUs, just a little bit extra, or if you're doing a snow melt system, the owners, you're doing some homes that are, high end, people want snow melt. heat pump may not be able to handle that. Twinning in a boiler to give to be used in the case of for the case of using it for snow melt is something that can be done. So you could use an electric boiler for that. So again, this lends to just tremendous flexibility. Like all of a sudden you're talking snow melting. They just want to snow melt the driveway or just a walkway or just in front of the house or something. So that is definitely, and it's, believe it or not, people do ask for it. Okay. Now this would be the setup where you're using it for your domestic hot water. So what happens is the unit will turn on and there's a three-way valve that sends the hot water directly to the tank to make domestic hot water. Again, you kind of have the same issues that you have with existing heat pump hot water heaters. You're only got 130-degree water to try and make domestic. So unfortunately, you're trying to bring cold water from 50 degrees up to 90 something degrees. It doesn't take a lot of BTUs. It just takes a great difference in temperature to do it. So unfortunately, what we're looking for, you may have to go with some, units with higher storage. But again, if you tie it in with the boiler, you could get away with making hot water more of a traditional indirect to make hot water quickly and not have to worry about storage and not have to take up a lot of room with big storage units. So definitely, there's a lot of things we can do here to make hot water and to make the whole thing efficient and also comfortable. A big proponent. I mean, it's one thing to make it efficiency, but if the people are cold, they'll rip it out and put in what they need to make themselves warm. So obviously, that's really important. Okay, and again, it can be done with the split box system as well. We put in we add in the boiler and we just parallel pipe it in. Okay. So that's kind of it for tonight. Hopefully we hit most of your things. I'll take any questions from anybody at this point.
All right, I guess I'll go first. I've got a lot of questions though. What is the loss?
Sorry, I lost you for a second.
Okay. What is the loss that you're seeing? Like, what's the efficiency loss that you're seeing as compared to a split unit? I don't know if that's an answerable question, but there's got to be a loss in terms of when you're going from air to water. What is that loss? And I'm not talking about a split. I can imagine that if you're using the split version, the loss is less.
From a standpoint, that's a great question. I wouldn't have a good answer for that. I don't, because it's really about, is there some loss of heat of the water traveling through the piping? Is that kind of what you're asking? Is that what
when you're transitioning
about those losses?
Well, I'm assuming you have some sort of energy transfer between the refrigerant and the water or the glycol. There's got to be some loss there. It is, I guess, would be only whatever is. What do you call that? What do you call the radiator panel? What the energy?
Yes, there's a COP number, I think, or something. Is that kind of what you're looking at? I think. Yeah, that one. I don't know that answer. It's not much. It won't be much.
Okay. And then I was going to ask you about what kind of water temperatures are we reaching? I think you mentioned about 130 is the maximum sort of for our area.
You're reaching about 130 to 140 degrees in the buffer tank.
Okay. And then what are you reaching for cold?
For cold, you're going down into the 30s.
Wow, that's okay. That's pretty cold. Are there?
The cold is easy. It's the heat that's the problem,
Right.
Refrigerant's designed to go cold. It's not designed to go hot.
Which would be good for a passive house type of building because usually you're trying to cool and less concerned about heating since we have all the internal loads.
Which is that's the beauty in this because you're unlike the refrigerant systems. Again, when you size it, again, if you size it for cooling, it's too big for heating, and they're not designed. And the problem with refrigerant systems, they don't allow you to kind of do that. Whereas in this case, you're heating the water. You can heat it and cool it as much as you want. It's not, it doesn't affect it. If you put in a big unit because you really need it for cooling and you're over big on heating, there's no loss. It doesn't matter because you're just running the water through emitters. You're not worried about refrigerants changing state and having enough air flowing over the coil to keep it cool so it doesn't, it stops from freezing. You don't have any of those issues. Because if you put in you put an air handler upstairs in the attic that does 2 million needs 2 tons of cooling, but you need, equivalently of 1 ton of cooling, heating in that same zone. You're running it through the baseboard. You're running water. It doesn't matter. It's not sized. You're sizing that. You're sizing the radiation for your heat loss of the house. So therefore, it doesn't matter if the unit outside is oversized or not. It won't matter.
My next
question doesn't have those effects that where the air conditioning, you've got the air moving all the coil, and if it doesn't have enough of a temperature difference, the coil starts to freeze up and create all those issues.
Right. The next question I was going to ask is the zoning solutions for a home. I imagine there's no off-the-shelf zoning solutions. It's all kind of custom built, like every other hydronic heating.
Yes, it's exactly. So what you're doing is you're taking out a hydronic boiler. You're just replacing the source of the heating from fossil to electric, to the heat pump. So the piping and all those things become the same, but it gives you that flexibility that you can design what you want. You say, like I said, the homeowner says, I want some radiant into my bathrooms, and I want some cooling upstairs. I want some baseboard, and you say, okay, I can give you zones I can zone off your master suite so that's the only room getting heating, and we'll heat the other rooms just like a traditional thing. I can run baseboard here and there, and downstairs they want to keep their cast iron radiators because they look nice and it's aesthetic to the house. Great. There's nothing better than only running 140-degree water through big cast iron radiators. It's the way they should be working now, but we don't. We run 180-degree water through them.
Is there, I'm imagining there's also a solution, as long as you don't mind getting a little complex with your distribution, there's probably a solution to share heat in the same home not share heat, let me rephrase that, transfer heat in the same home between zones. So if your finished attic is always too hot and your basement is always too cold, there's probably a way to move glycol from fan coil units to transfer that heat from the attic to the basement and even out the zones. I imagine it would get complicated, but there's probably ways to do that. Isn't that right, Brendan?
That would be complicated. That would be complicated. I'm not sure how practical that is. You have to do it as a separate system.
Right. Are there any makes of this, I mean, you called it an appliance. Are there any makes that are super helpful in communicating with architects for if they want help? I mean, like if I need split unit help, I can contact you.
Yes.
What are those makes?
Yes, the same companies are the same. Yeah, the same companies do that. Plus us as a rep can do that. So you can contact us as a rep, but like SpacePak is one company that we rep. NTI is a company that have just launched one. So same kind of, almost kind of hard to see that here's the same names that you're used to dealing with on the refrigerant side doing this as well.
Oh, you're saying the big refrigerant?
But yeah, the same things that you're used to getting. Yeah, you'll start to see some of them coming out with heat pumps as well with these air to water setups.
But you said
my particular company, we rep.
You said right now there's only 2 sizes for homes, and that's the 30,000 and the 60,000 BTU.
No. Yeah, there's only 2 sizes. Yep.
But I imagine because you're using a buffer tank, perfectly sizing it for the loads is no longer a concern, like it is with a traditional split unit, refrigerant split unit. Is that also correct?
Correct.
You
Correct.
would you would be
What
okay
it
with,
would be, what would be more critical is the load calculations for each space. So the emitter that you want to put in the bedrooms would be sized accordingly. So that's what becomes important, but not the critical mass that the refrigerant lines have. So that's what you'd be sizing. You'd be sizing the size of the radiators that you need in the bedroom, or the amount of baseboard that you need in the bedroom. That's where your load calculations come in.
and when the zoning is calling for on and off to each individual space or room or zone, what are you exactly controlling? Is it a pump that turns on and off? Is it a pump speed? Is it a
Correct.
valve?
It can be zone valves, but for the most part, it'd be a circulator.
A circulator. Um,
Yep.
okay. And I think that's it. That's all my questions. So I know there's a lot of questions. I stole a lot of people's time, but this is really fascinating stuff.
There's a couple questions that came up in the chat.
Okay.
Do you guys, the guys that presented those questions, do you want to just go ahead and ask? Or would you like us to read them out?
It would be better for me. Yeah.
You want me to read them?
Is it Kaylin? You had a couple questions. The first one was, what about using hydronic radiant cooling emitters and dew point control?
Yeah. So you can use the beauty in this, the advantage of the system is that so you have this buffer tank, and during the heating season, the indirect your unit is filling it, is making it a tank of hot water that then the circulators take that hot water and send it to the emitters. Now come summertime, you're switching, that unit goes and makes that tank filled with cold water for cooling, and then you're taking that cold water and sending it to emitters. So yes, you can use the same emitters like you do now with the refrigerants, where it's a little emitter with a fan in it that can be used for both heating and cooling in this setup. Or you can keep it separate. You can put a unit in that just is used for the heat for cooling, but you're using something else for heating in that room, like radiant. So we're going to radiant the room. We're going to put the radiant in the slab, and we're going to radiant, they have old tile on the first floor of the house. So we're going to radiant that for heating, but for cooling, we're going to put the emitters throughout the first floor and run cold water to that during the summertime.
I
Was
couldn't tell.
asking about the
Did
price?
you address? Yeah. Oh, that was the last one. The one that just came in.
Okay. The pricing is more.
Sorry, the pricing is more than.
Yeah, it's significantly more.
Than a traditional hydronic boiler.
Yeah. No, not a traditional hydronic boiler. Yes,
Yeah,
in a traditional hydronic boiler, yes, it would be.
Well, of course that would be the case, but is it also because, is that it? Is that the only reason it's more, or is it also because I assume the distribution is no more than any other hydronic distribution?
No, the hydronic side of it is the same, whether it's a boiler or the heat pump. So that's from that pricing, it's about the same. The pricing of the unit between the buffer tank and the unit outside, depending on where you go, that can be, it's a little bit, it's probably about 50% more than the boiler.
Which makes sense because boilers are very, very simple. I mean, they're super simple appliances.
Cast iron, and they've dated and everything else. So the newer, with the refrigerants and stuff, you're probably looking at about 50% more. But now, regarding putting in this system as opposed to your refrigerant systems, it probably is a lot more, because you've got all the hydronic stuff going in, plus the heat pump side of it. So that pricing does go up compared to doing just some mini splits throughout the building. If pricing is an issue, there are other tricks too. You could actually use a heat pump hot water heater. You guys, I know that you guys have been working with those to make hot water heaters. You can actually use that as the source of heating. It's almost like a buffer tank and a heat pump in one. So if you were dealing with a house where you're not dealing with a tremendous heat loss, your load is not very big, and cost is an issue, that's actually a little less inexpensive way to put in that same system.
I don't follow that, Brandon. You're saying use a heat pump water heater, but wouldn't that, if you were using, I have a heat pump water heater in my home, but
Right, so
everything
you take that heat pump water heater, and instead of using it to heat water for your domestic, you're using that to heat the water to heat the house.
But if you're talking about the units that are fully integrated in one unit that's inside the home, I can't imagine that would work, because then you would be using up all the heat that you're creating to then heat up the water that's going into the system. It would be a loop that would just be never ending, wouldn't it? Am I thinking about this wrong?
That's the disadvantage of those heat. Yeah, the disadvantage, as you know, with these things are you're taking heat, and exactly, you're taking heat to use it, and then you're dumping cold air into the house. So
right, which
now,
then makes,
unless you do it where you duct it, which is another option. I'm just saying there's an option there to go less expensive. It can be done. May not be the most efficient way of doing it, but it's less expensive units.
Rabbi is saying with the outdoor unit, like ecological
Right.
heat launched. I'm assuming he's talking about where the condenser for your hot water tank is outside of the home. And then, yes, I would agree that that would be a really good.
Right.
Someone had a question about what are the risks of condensation managing humidity?
Yeah. So with obviously, yeah, with the chilled water, if you use them as chilled water lines, yes, insulation would become critical. You'd have to make sure you have good insulation around the piping, and no drafts, to make sure you don't have any condensation issues. Absolutely.
What about condensation on the emitters themselves?
No, well, they're designed for it, right? You're not, you're going to be using emitters that are designed for both heating and cooling.
Yeah, but the humidity is changing usually.
Right. So so in putting one of those emitters in again, then you're going to have to make sure that you, in the design, they, in those instructions have for a drain to get rid of the condensate. So that would have to be a factor into what type of emitter you want to use.
Yes, if we're talking about fan core unit, yes, condensation actually is good because it provides ability for dehumidification,
Right.
humidity control. But if we're talking about radiant ceiling, for example, or radiant floor,
no, the radiant floors and that's just for heating. I'm not saying to use that for cooling. You're not. I didn't say you're not going to be piping. You can have that with it, but it's not going to be used for cooling. So in the summertime, you're going to take the cold water that you're making and send it to an emitter for your cooling. And in the heating, you're going to send the hot water through the radiant floors.
So by emitter, cooling emitters, you mean only fan core units, but not the radiant cooling emitters,
exactly.
correct?
No, you're not radiant cooling. No.
But is it because you don't recommend this as part of your system, or because there are solutions that are offering these capabilities, like low thermal mass panels for ceiling or for walls? including
If
floors.
you want to, if you know about that and would want to design into it, again, that's the flexibility in this, that you're dealing with water. And the idea is, that's the beauty in this essence, exactly. The beauty in this is that you're dealing with hydronics. You're dealing with warm water and cold water, and you have all these options open to you. So if you wanted to do that and had the solution that, hey, I want to send cold water through, I'm going to use it for heating and cooling, and yeah, absolutely. And you find the appropriate tubing for that, or the appropriate system for it. Absolutely. But that's the beauty. That's what we're opening up here, is that you're going to the world of hydronics, and it just opens the world of possibilities.
Absolutely agree. Hydronic is the best possible system to condition a space. No question about it. Much more superior than air.
Yep, absolutely. So that's what this, these air to water heat pumps are providing. And I think, again, with the new refrigerants, there's going to be a big pushback on, because they're going to go towards more of a flammable type of refrigerant in order to get to where the temperatures can deal with colder temperatures and give us hotter water. Having a unit that's already sealed, packaged from the factory, UL'd, is going to open the world to that. Whereas no one's going to want, propane running through tubing that guys installed in a building. I mean, there's already issues with it, right? They don't know what to do with the A2L. Do you have to vent it? Do you not vent it? The codes are all over the map with that. So, but that's where this really, these appliances could blossom into that.
I mean, in our experience working with radiant cooling panels, it works. The secret is to work with a low thermal mass system. So the system can detect a change in humidity and adjust very fast the dew point, adjust the temperature of the emitter. So
Okay.
if you work with this kind of system, it's absolutely doable. We have done this with Mesana, with OpenOR panels, Thermahex.
Great. Okay, absolutely.
Yeah, and SpacePak works great with this system.
Yeah, it would. It sounds like it would. Yep.
Brendan, could you speak to the question about the SunAmp phase change heat battery?
I'm sorry again.
Could you answer the question in the chat about the using the SunAmp phase change heat battery to
I'm
replace the
not
buffer
familiar what
tank?
that is.
Yeah, that's one of the questions that I put on the chat. Again, this is Colin. So SunAmp are offering a heat battery, which is about 1/3 of the size of a regular water heater tank for the same energy density. And it's filled with the phase change material, which can absorb much more heat energy. So I mean, from what I was seeing, in my opinion, you should be able to replace it. But I was just curious if you have tried or not to replace the buffer tank, just because it will save space.
Oh, okay. Yeah. The question would be, yeah, space, and yeah, can it, you want to be able to, the tanks are sized to make sure you can get heat to the house, and it gives you that extra bit. It gives you the extra storage of BTUs because of the in the house. But yeah, all that stuff's going to be could definitely work. But